Welcome back to the channel. Today is episode number 2 and part 2 in our series on cooling towers. In part 1, we talked about counterflow and crossflow towers, as well as closed circuit fluid coolers and a comparison between closed circuit fluid coolers and open towers. Today, we're going to take a little bit of a step back and talk about the components that make up the cooling tower as a system. And then we'll also talk about some common accessories that you'll find in towers here in Ontario today. So thanks for joining us, and here we go. The purpose of any cooling tower or evaporative cooling device is to exchange energy, thermal energy, between a working fluid and outdoor air. Now, on a cooling tower, the fill is the business end of that heat transfer process. Now, you also find fill in evaporative fluid coolers as well. As a side note, dry coolers, as per their name, don't use evaporation to exchange energy. So a dry cooler wouldn't have fill. A dry cooler is simply a closed circuit coil placed in an airstream, and it's rejecting heat from that coil into the airstream. Now, the fill most commonly today is a film style fill, and it's designed to provide a large surface area for the working fluid to flow over. A film of water is formed on the surface of that fill, which allows for the most efficient transfer of energy. The tower's spray nozzles above the film are set up to distribute water in an engineered manner to optimize the efficiency of that fill system. Along with the fill, you'll also find drift eliminators downstream of the fill inside the cooling tower. Their job is to reduce drift, and drift is the unwanted loss of recirculated water or that working fluid from the tower. So the eliminators are placed downstream of the fill to try and capture any water droplets leaving the tower unwanted. And they're typically pretty efficient at doing this. Towers today will have a drift loss of less than 0.002%. The basin makes up the bottom section of the tower, and it basically collects the supply water for the condenser or for the heat pump loop after it's released its energy to the atmosphere, to the outdoor air. Typically, the basin is an integral component of the cooling tower unit itself, but sometimes you'll find it as a remote basin, and that's applied in cold climates. But even here in Ontario and Canadian climate, it's a very rare to see remote basins. There may be particular reasons why an application would go that route. Most commonly, what we find is basin heaters applied in the basin to protect the basin itself from freezing. Now, in comfort cooling applications, typically the tower will be drained in the fall season, and it'll be empty through the winter, as you don't need cooling in the wintertime. If you do forget to drain that basin, the basin heaters are relatively inexpensive insurance to protect the basin from any unwanted freezing. Now, with that, the materials of construction of the basin are also very important. Commonly, galvanized G235 is applied as a standard basin material, but in areas of poor water quality, the 304 stainless steel can be applied. Now, the additional cost to go to a stainless steel like that is typically 10 to 15% on the total cost of the tower, but the added life that you get from that basin is tremendously extended. So it's a great option to add. While we're talking about basins and draining the basin for comfort cooling applications in the winter season, you may also have cooling loads in your building in the winter season, and this is the advantage of the closed circuit evaporative fluid cooler. In the summer season or in the peak cooling season, that evaporative fluid cooler could be running wet, so you're running the basin is filled, the spray system is running. But as you get into the shoulder season, you may be able to run that fluid cooler dry and still meet the cooling load of the building. I mean, depending on what the building loads are. And we can also look at that up front in the design to say, okay, well, we want to make sure we get a certain capacity out of this fluid cooler when it's running dry. And the advantage that Evapco, I've been showing some images of the Evapco product here, as a manufacturer has, is the capacity of those coils, the eco fluid coolers that they have when they're being run dry. So considering that water is a precious resource these days, and so is, the cost of sewage and the cost of water treatment, minimizing the use of water on any cooling tower should be a key priority. And closed circuit fluid coolers, evaporative fluid coolers, allow you to shut the water off. Now on the fans, there are two styles of fan systems in any cooling tower. We talked about induced draft in the previous episode, and there's also forced draft. Now, induced draft fan systems use an axial type propeller fan to induce airflow into and through the tower. Manufacturers will offer different versions of that axial fan. Some will offer a super low sound fan style. Now, if you have noise restrictions for the application, these super low sound fans are a huge benefit to reduce overall decibels. Okay, so where are you going to find forced draft equipment that you wouldn't find induced draft equipment? Forced draft fans can handle external static pressure. So anywhere you need to duct a fluid cooler or cooling tower is where you'd apply that equipment. And that's typically in indoor applications. So you might have a cooling tower in a mechanical penthouse, and so it's ducted outdoors. Or anywhere, indoor or outdoor, where you need a low profile setup. So manufacturers will build low profile cooling towers and fluid coolers using forced draft equipment. Okay, last but not least, we want to talk about accessories a little bit here before we run out of time. I'm trying to keep these less than 10 minutes. So we did talk about a few accessories during the course of this episode. We mentioned super low sound fans as a great way to reduce decibels on induced draft towers. With that, there is also sound attenuation devices for forced draft towers. So intake sound attenuators and discharge sound attenuators to bring the decibel rating down on that equipment. We also talked about basin heaters and application of basin heaters as great insurance in cold climates. In addition to basin heaters in the basin itself, we have level control systems. So typically, standard level control is a mechanical float valve, which can be upgraded to a electronic level control, either a 3-probe, which gives you a high and low cutout, and then a grounding probe. And then you can upgrade the 3-probe to a 5-probe. Let's say if you wanted to incorporate this into your BAS, you get a high alarm and a low alarm, which you can tie into that BAS. And of course, one more accessory I'm going to mention, which is pretty common, is just ladders and platforms to be able to access the equipment for maintenance. So that's all for this week, keeping this to less than 10 minutes. We're going to have more on cooling towers, probably more in the design and application and selection of cooling towers and some of those fundamentals. So stay tuned for that, and we'll see you on the next one. Thank you.